ये जो ऊपर लिखा है वीक टू एन डॉट, ये जो क्या है, जो वो क्या कहते हैं उसको, एक्सटेंशन क्या है ये, IPYNB?
ये फाइल का नाम है वीक टू और न्यूरल नेटवर्क डॉट आई पी वाई एन बी। IP.IPYNB बेसिकली जब हम जुपिटर नोटबुक बनाते हैं तो उसको सेव करने का वो है फाइल टाइप .IPYNB। जैसे
अच्छा।
PDF होता है वो
हाँ।
.PDF में सेव होता है। और वीडियोस जनरली .MP4 या फिर .WAV में सेव होता है। सिमिलरली जो ये दो जो अपनी क्या कहते हैं जुपिटर की इस टाइप की फाइल्स होती है ना वो हमारी .IPYNB फॉर्मेट में सेव होती है।
अच्छा ठीक है।
ओके। सो
समझ गया।
मैं ये कोड सिर्फ इसलिए दिखा रहा था कि आई मीन और ऊपर ऊपर से देखने से ओके। लाइक अगर मैं बात करूँ like do you think it's interesting, I mean to be able to do this? Well, it's a question, yeah, see, you have an
बहुत
idea
भाई बहुत
and
इंटरेस्टिंग है।
yeah, exactly, you have an idea, you
हाँ।
know how to implement the idea. Okay, you can actually to be able to implement your idea and solve complex problem with the help of computer. That's computer science. Okay, we will try to cover the basic difference of computer science and software development, और लाइक स्वप्न सुना होगा कि डीएसए कर लेते हैं वो कर लेते हैं, उन चीज में डिफरेंस क्या है और एक्चुअल जो कंप्यूटर साइंस की बीटेक की डिग्री होती है उसमें क्या डिफरेंस है। ओके, वी विल ट्राई टू जस्ट टच अपॉन इट। आई थिंक इट्स एन इंटरेस्टिंग पॉइंट। तो हाँ, सो मैंने क्या पूछा था कि डू यू थिंक इट्स इंटरेस्टिंग टू बी एबल टू डू दिस? गेस व्हाट, इट्स
Yes.
सुपर कूल।
Yes. Hello.
ओके, इट्स सुपर कूल एंड
Good
इट
afternoon.
फील।
Hello.
हाँ
हेलो।
हेलो। हाँ
नहीं भाई,
हेलो।
ओ गलती से गलती।
ओके ओके, नो प्रॉब्लम। हाँ, सो तो सी सो कहा था मैं? हाँ, so yeah, it's super cool and it's feel fucking amazing. Okay, like let's say you have your machine learning algorithm. Okay, don't go into the complex terms. I will explain it later. Maybe, not sure. Okay, so you have a machine learning algorithms. You are running for it 100 epochs. Epochs mean loops. You are running the algorithm for 100 loops, let's say, and your accuracy is going high. Okay, let me just show you some actual data. So this is the model where I was you know training my neural network to recognize this image of Bart and differentiate with this image or this person or from Simpsons. Okay, so that was my basically kind of an assignment. You can take that. Okay, so I was running. So this is called loss function. We will discuss it maybe in session 2 what exactly a loss function is, what exactly epoch is, but you can think of it as that after each iteration we are our main objective is to minimize the loss. Okay, so minimize the loss and see our accuracy is now soaring high, 90%, 95%, 96%. Damn, that's cool, at least for me. Like, that's what I think about it. Like, for a second, just imagine uh, your computer is able to recognize a picture of a cat because of you. Your computer is nothing more than a brick. If you don't know how to use it, accordingly, you don't know how to program it. It's of no use. Exactly of no use. Because I'm not talking about the actual user experience or interaction with the computer. I'm actually talking about you can the actual use of computers, which is to solve complex problems and image recognition. Here I talked about image recognition, which is also a complex problem. Okay, we will maybe touch upon it too, with that what's image recognition, how it works, etc. And see, for this model, we have an accuracy of 100%. That means that in our sample space, the model is able to predict with 100% accuracy that this image is of Bart and this image is of Homer. That's the magic. That's the kind of thing we really want to learn. We really should learn, and we'll try to understand why we should learn in today's session. Also, uh, we will discuss that why it's not a big deal to be able to do this. Why everyone can do this. Okay. So Balak and Balika, I'm not in the literal sense, but yeah, myself, Dhruv Chaturvedi.
आपका आवाज नहीं आ रहा भैया।
नहीं दिखी है।
उससे मीटिंग लीव हो गया एक्चुअली दिस वीक फॉर अ मोमेंट ही विल बी बैक वैसे किसी को आज ऑडियो इश्यूज तो नहीं आ रहे थे वगैरह
नहीं नहीं, बढ़िया बढ़िया बात है।
नाइस नाइस
Crazy day. Okay, let's go. So Windows. Yeah. So this is our basic checklist for today. What we are going to cover. First of all, let's see. Let's understand a little bit about CS. And in it, we will cover that what is the basic difference between computer science engineering and software development. Okay. So to explain, I will take an example. Let's say you are a chef, okay, who want to make a sandwich. So to make a sandwich, you need, let's say, 2 pieces of bread, peanut butter, maybe jam, and a spoon. Okay, that's it, to spread or to make a sandwich. That's it. So, but the thing is, that's what actually software developers do. They use the available things to make something. What they use, the bread, they use the peanut butter, they use the jam to make a sandwich. They are not producing the jam, they are not producing peanut butter, they are not producing bread. And the production of these things are the task of an computer science engineer. By that, I don't only mean that कि computer science engineer का जो task होता है वो सॉफ्टवेयर डेवलपर नहीं कर सकता, फिर सॉफ्टवेयर डेवलपर का जो टास्क होता है वो कंप्यूटर इंजीनियर नहीं कर सकता. ओके, लाइक मे बी यू कैन थिंक ऑफ इट एज कि जो बेकरी वाले सैंडविच बना सकते हैं, एंड जो सैंडविच बनाता है मे बी वो भी बेकर हो, बट माय argument is here this basic difference with computer science. You are actually learning about how computers are working, how different how different types of technologies inside of computer, different types of software, different types of software making methodologies, okay, terminologies, how are actually they gonna work with each other. That's the task of a computer science engineer. Okay, also they make websites and games, that's other thing, but you don't actually need to know how these tools are working. Okay, let's say you want to learn Python, you don't have to actually learn how Python is working. Okay, you just need to know basic syntax and you are good to go. You are good to write simple scripts in Python, simple command line tools in Python, or write simple games in Python. You don't actually need to know how a Python is working, although we will try to get a overall understanding how programming languages work. Okay, that's the major difference between computer science engineer and a software development engineer. Now, why there is such a hype about this industry? Okay, why there is such a hype about this industry? Okay, I want to make sure ki, am I audible? Yes.
Yes, perfectly.
Yes.
Okay, nice. So, eating break for very nice. So, why there is such a hype of this industry? So, first of all, obviously there is massive growth in this industry. Okay, there's artificial intelligence. There are like each year you have something new, which obviously computer scientists who came up with, like let's say artificial intelligence. Some maybe after 2 years, let's say some computer scientists created a new algorithm of artificial intelligence. Okay, you have heard about that artificial intelligence will take over the world, kind of similar to that, like he's created some new algorithm. Now there are a lot of jobs or learning opportunity that has created in that field. Also, along with there are some jobs which are going to be eliminated from this field. Okay, you may heard of that AI took over this job or took over these industries. That is half truth. Also, because of AI, there are multiples and thousands or lakhs of new job which has been created. Okay. So the reason behind hype is that there is massive growth in this industry. You can do literally anything. You can implement your ideas. Each and every industry on this earth need a computer science engineer. If you are in mechanical, you need someone to make softwares. Okay, software like Fusion 360, AutoCAD, okay, or like complex simulation software like computer fluid dynamics, finite element analysis, structure analysis. Same if you are in chemistry, you need someone to make software for molecular analysis and things related to that in each and every department. And that's vice versa too. In most of the cases is okay. So you may get the idea that why there is such a hype about this industry and why everyone should know it. Because obviously, if you, let's say you are not a computer science engineer, which is the case of this is the most general case in this session. Okay, and so let's say you are not a computer science engineer. You are a mechanical. You are in mechanical engineering branch. Okay, specifically to IIT Bombay. So let's say you want to work on a complex problem of computational fluid dynamics. You are working on a car and you want to run simulations on it. Okay. So you are running simulations on it. Let's say aerodynamical solutions. You need to actually calculate like how aerodynamic is the car. So you need a little bit knowledge of computer science. Not only that, let's say you are working on some project in mechanic which is related to mechanical engineering, and there are no one from CS department which is able to do your project because it needs a good knowledge of mechanical engineering department, and by that project you are actually going to improve your whole department, not in only.
So, hello.
Okay, I just got a call, sorry. My bad. Let me just, okay, so you are reshaping industries with the help of the knowledge of computer science. So take it computer science as a tool, okay, as an engineering tool. Like if you know calculus, it's beneficial for you. Like in your first year, generally in IIT Bombay, you are being taught some basic math courses, like linear algebra courses and calculus. Okay, multivariable calculus and stuff like that. Okay, so the thing is, these are mathematical tools which you can use in your department over the period of your study. Similarly, computer science engineering also provide you with some tools which you can use in your department. You will, when you will come to your colleges, you will understand what I am trying to say. Okay. Give me 1 second, please. हाँ, सो मेरे पास जस्ट अभी एक फोन आया, तो आपस में लोग मीटिंग में एक दूसरे को रिमूव कर रहा है. सो यार, आई होप कि यार ऐसे ही हरकतें ना करो, सेशन पे फोकस करो. एंड ऑब्वियसली द इशू इज कि मैं जो ये मीटिंग कर रहा हूँ वो कर रहा हूँ एज एन ऑर्गेनाइजेशन फ्रॉम IIT बॉम्बे, एंड यू आर नॉट द मेंबर ऑफ IIT बॉम्बे, सो यू विल आर नॉट बी एबल टू चैट or attend the meeting as an attendee. So you have to keep up with this. Okay. So don't remove anyone from the meeting. If you have privileges, just sit tight, use mic, use your webcam or whatever, and just attend the session with full engagement. Don't do these things. Let's move forward. So now I will talk about some basic computer logic. Now, what the heck programming is? What the heck programming is? Can anyone answer?
Programming is like talking to the computer.
Yeah, good, right. So programming is like talking to the computer. You are trying to, you are making computer understand you. So let's say we have this computer. Take computer, assume computer as a black box. Like we know this black box is able to do many things, but we don't know what happened inside of this black box. And you as an end user, what you are trying to do, you are giving it some set of instructions. Hey computer, let's make a sandwich. It is similar to that. Hey computer, let's make a sandwich. You given the computer a set of instruction like that. What's our instruction? Let's see. So let's say, hey computer, this is just an example, don't take it literally. The computer is not able to make sandwiches. Okay. So hey computer, take 2 pieces of bread, and hey computer, to take 2 pieces of bread, take 1 jar of peanut butter, take 1 jar of jam, and then make a sandwich. So what is this? This is a set of instructions we are feeding to the computer. In our case, it's, let's say, a person, you have your brother or your sister, and you are asking him or her that make a sandwich for me, and he or she asks for the instructions. She don't know what a sandwich is. She don't know anything about sandwich. She don't know how to make a sandwich. To explain, you take 2 pieces of bread, take 1 jar of peanut butter, take 1 jar of jam, apply, and then make a sandwich. Okay, you can also include more statement like apply peanut butter on one side and apply jam on other side. Okay, and now make a sandwich. So what are these? These are some set of instructions we are feeding to someone. So similar to this, what computer does, it takes a set of instructions from a user. Okay, so this is our user. Okay, this is a user, gives instruction to our computer, this machine. Okay, this is our computer. It gives instruction to this, and now the computer is able to execute these instructions line by line, and we will understand how this thing also works. Now you will ask me, or I'll ask you, that how the computer is able to understand the basic knowledge or basic English. Uh, for example, if you ask a Chinese person, do you know Hindi? He obviously don't. Okay, he doesn't understand Hindi. He has his own language, Chinese, in which we have to first translate our Hindi to Chinese to make him understand what we are trying to say. That's the point. That's the point. That's we are going to do. That's what programming is. That's the essence of programming. Okay. So we are trying that if we talk Hindi and computer talk Chinese, that we have to convert our Hindi to Chinese, then feed it to the computer. That's what programming that's what programming does. Okay. So let's see what's the some logic behind this. No, there are some, again I will make some more black boxes. What a black box is? Black box is something which takes an input and outputs something, and we don't know what's happening inside of that black box. Okay, that's a black box. So let's say this is our computer. This is our program, and this is something that converts our normal language. This is something that converts our Hindi. एक second. That converts our Hindi to Chinese. Oops. Okay. Now, what is this? This is a translator, right? This is the translator. It translates Hindi language to Chinese language. Now, again, whatever we feed this thing, okay, this kind of loop always happen in our computer. Like almost all of the time, this thing is happening. Okay, and we have some output here. Let's say you have displayed as some image over on computer. This is an image you have displayed on computer. Okay, right. That's it. Not, but computer does not understand Chinese, nor it understand Hindi. But computer does understand binary. Okay, ones and zeros and ones and zeros and ones and zeros and ones and zeros. That's the language of computer. Okay, that's what computer understand. We as a human understand basic English. We understand some basic syntax. So what we did, we created a layer of abstraction. What layer of abstractions are? Let me explain. Here, first, this is our programming languages. This is where we done programming. And this is called our compiler or interpreter. We will understand what compiler or interpreter in a second. Okay, let's see. Let's see what is abstraction exactly is. Let's say this is some level that computer is working on. By level, I mean that let's say you are working on hardware level. Okay, you are putting microchips, you are connecting transistors to with each other, you are making binary logic. most of you have studied logic gates in class 12. You are connecting, okay, so same thing. You are connecting logic gates. You are creating logic with the help of semiconductor inside computer. And logic gates generally have two inputs, 1 and 0. Okay, we have not gate, ignore that. We generally have two inputs, 1 and zeros. By that, we understand that most of the memory, information, data, or anything that's inside our computer is stored in the form of binary. So we are working on the level of binaries. Oh, binaries. Shit. Ones and zeros. So we are working on the level of binaries. As a fellow human being, we are not tend to understand the language of computers. We don't know how ones and zeros actually interact. We can solve logic gates, but there are trillions and millions of different connections inside our CPU. So we can't actually do that on our hand or even on calculators that are present. So we created some simple binary instructions and created a level of instruction higher from this level of instruction, higher from this level of working. So this is our second level where everything works. This is the level of assembly language. Now, what assembly language is? Can anyone have has any idea what assembly language is?
I think that
Like,
assembly language is the first programming language or like
Assembly
most,
language is used on directly on my processors.
yeah, like it's the, like direct language that the computer understands.
Like
yeah,
8085.
exactly. Very good. Nice. So the thing is, now we are on the level of assembly. Now, to understand what assembly is, now let's go again here. Let's go back. Let's go back. Now, let's say this is our assembly. This is our assembly. मतलब ये इंग्लिश को क्या हो गया यार, सारी स्पेलिंग्स में गलत स्पेल कर रहा हूँ. Okay, so this is our assembly. Don't go on the spelling. So this is what assembly is. Okay, so you can think assembly as a set of instructions. Again, we are giving giving computers a set of instructions. So assembly is just in a level of abstraction above the level of binaries. Okay, I'm using the word abstraction here. Okay, I'm using the word abstraction. Abstraction. It's visible, right? So what abstraction is? It creates it's kind of hide some complex details and give us control over the more specific things or more useful things that we want to work on. It gives a more high level understanding of things, how it's working. Okay, so there are two levels of understanding. So first is low level and then there is high level. So the binary is the low level. Low level by means close to the hardware, close to the CPU, close to the binary set of instructions. That's low level. Now you have created a level of abstraction above that, which is one level higher than that level. That is the level of assembly language. Okay, and the purpose of assembly language is to give a set of instructions to the computer, and there is a program which is being used in between that, and we call it assembler. Okay, so in the case of language translation, we called it translator or translator, and in the case of translation from assembly to binary, we called it assembler. It assembles the assembly instructions and feed it to our computer in the form of binaries. I know थोड़ा ऐसा अजीब complicated सा लग रहा होगा मे बी कुछ लोगों को सुनने में, but it's better if we from start use the actual words or the actual the actual jargons or terminologies which are used in computer science. And still अगर किसी को ना समझ में आ रहा हो या फिर मैं ऐसा कोई word बोल दूं, so you can always ask for more explanation over this. So is assembly clear to everyone? Like what is the overview of assembly? Okay, just raise your hands. Nice, 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 nice. Let's move forward. Now, with time, initially what happened that only scientists used computers, okay, because of the task like solving some big equations and or you may have watched there is a popular movie, okay, uh, the I forgot the name, but yeah, it's a popular movie about Alan Turing. Okay, he made a computer to solve Enigma problems.
The
Okay,
imitation game.
to imitation game, right? The imitation game. Yeah. So what he does, he so what happened at that time? There are mathematicians and scientists solving the cryptographic hash functions for the Enigma. What cryptographic hash functions are we going to discuss cryptographic hash functions? No, we are not going to. But I will try. Okay. बस कोई मेरे को याद बाद में एक बार याद दिला देना. So what he does, he created a computer which can solve like thousands of hashes in seconds or in minutes. Okay, and which took like months or even years. And like there is a popular saying कि एलन ट्यूरिंग की वजह से काफी हद तक वर्ल्ड वॉर जीतने में मतलब अलाइड फोर्सेस को वो मिला था मतलब साथ etc. Whatever you want to say. Okay, so yeah, that's it. So now moving forward. Now, what happened that engineers saw the opportunity to not only engineers, obviously, the scientists created new languages at Bell. They created C, they created Fortran, they created multiple languages. Like you have heard about C, but before C there was B, then and before B there was A language. But yeah, A, B, C, and in chronological order. That's different. So talking about it, so they created a different level of abstraction, a level up higher than this level. This is the level of assembly. Let me name this. Let me name this assembly ASM. That's it. Now they created one more level of abstraction here. Okay, we are not going to create more levels. It will just create more confusions. So as of now, this is the level on which we are going to work on in our session 2. Okay, we will try to understand how to actually code in some language. Let's say Python. Okay, I choose Python because Python is close to English. Okay, its syntax is close to English. The syntax of assembly is not close to English. It's very, very close to binary. It's English. It's even though it's English, but it's very close to binary. It's very close to hardware. It's not that intuitive. It's just set of instructions in which we are taking certain parts of memory, moving it somewhere, accessing it. That's not at all intuitive to me. At least I don't find it's intuitive. Okay, but programming is highly intuitive. Okay, you know what you are doing. You don't have to actually think in terms of instructions. You just have to know basic idea of what each syntax mean, what some basic things means, whatever the library you are using, whatever the API, you will understand what API is. We will understand what libraries are, but you will get the idea that the programming languages are a way for us humans, a common person, a first year, second year, third year student to be able to program a computer. Okay, not but yeah, most of the time we are going to use these languages. Assembly and binaries, some later on or like deeply talked stuff about embedded systems. Embedded systems again go with the word. Embedded means embedded in the world of hardware. That's what embedded is. Okay. Now moving forward. This is the level of our programming. This is the level which we are going to discuss. Programming. Okay. Zoom, 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 zoom. Now see. This thing is complete, computer logic completed. Now we will understand some basic structure of programming. Like there are some basic rules that every programming language has to qualify to be able to call that language a programming language. Otherwise, there is no use of it. Right? That's just a toy language then. Okay. Toy language is the language which we use just for fun. I mean, you created some random languages which does not have any functionalities of addition, subtraction, but this is you have that language. There is this. It's of no use. Okay, that's why we called it toy language. It's like a toy. It has no real use. Okay, now let's see what we can study about programming or what we can discuss about programming. A beautiful topic, programming. Now, let's understand how. So I talk about this thing, the translator, the assembler for the assembly level of instruction. Now, programming also have to go from here to here to the binaries, right? These programming languages have to be compiled or interpreted to binaries. Now note it. I used two words, compiled and binary. Oh, compiled and interpreted. So I can loosely classify languages in two categories. Okay. I'm using the word loosely because there are some more level of understanding you can get into it. Like there are several types of compiled languages, there are several types of interpreted languages, but that is just out of the scope of this session. We'll just understand all of these things. Okay, so this is our interpreted languages. Interpreted languages, and yeah, this is our compiled languages. Now we will try to understand what is the basic difference between a compiled language and an interpreted language. Now, let's say you have a book. Okay. You have a book. It's in Japanese. You want to understand the book. So you either convert that book, you translate that book to English or Hindi or whatever language you prefer. Okay. You have a book. This is your book. Let's say this is your book. Uh, uh, Delete it. This is our book. We have some very basic set of instructions. Why? Close lenses. अरे क्या हो गया? This is our book. This okay, book बन गई है. So let's say Japanese man. Okay. Now our task is to compile the book or interpret the book. Now go with the words. What did I say? Compile the book or interpret the book. So when I say compile the book, you are compiling the entire book from Japanese to Hindi, for example. Okay. Or you are interpreting the book line by line from Japanese to Hindi. That's the difference between an interpreted language and a compiled language. Oh, sorry, compiled languages and interpreted languages. So you have your compiled languages code here. You have your interpreted language code here. Okay. Let me just, this thing is red, green. This thing is red. Okay. What actually happened? That this code, this code is going to be compiled by the, again, what I said, compiled like entire. So entire thing is going to be compiled at once, and the software or the program, ये क्या हुआ? तो blob बन गया. Okay. The software we use to compile this thing is called a compiler. So for assembly, we use assembler. Similarly, for compiled languages, we use a program called a compiler. Let's just say compiler. Okay, happy? We use this compiler that compiles our language. Compiler languages to binaries. That's just this use cases. Okay, there are multiple use cases of a compiler too. We can talk about it in later sessions in detail. Okay. Now, what is the use case of an use case of you? Now we will talk about use case also. Now, what is that interpreted languages? It is being interpreted line by line. Okay, I will use red color for this. So we will take this line. Okay, we will take this line. Understand what has been written there, and use a software called interpreter. Now we will use for interpreted languages. We will use a software called interpreter. Interpreter. We will use this software, which take these take all of those lines. So take this program line by line, execute each statement, convert that to binary instructions, and those instructions came up to be our output as an output. Okay, let me just take a small demonstration here. Okay, of a compiled language and a interpreted language. There is no. I will just create a new file. File. Not even a Python. Let's say this is our terminal. Okay. One more thing. So in our list, there is a topic called CLI. We are again going to come back. Come back to this. Okay. So first of all, we will understand what interpreted language is. I will instantiate a Python instance. What instantiation is? I use this Python keyword. I typed it in the in my terminal or command line interface or CLI, and I instantiated an instance. By instantiated, I asked, okay, yaar, give me the tool or give me that interpreter, the access of that interpreter to me. Okay, I instantiated it and created an instance created a copy of interpreter in the memory. समझ में आया मैं क्या बोला? आया? I guess आ गया होगा. Moving forward, let's say initialize the variable a. A is equals to happy. But let's say, so what is the syntax? What is happening? Don't worry about it. Sorry. हाँ. So don't worry. क्या लिखा है मैंने यहाँ पे? Just go with the flow. Okay, A is equals to happy. Okay, A is happy. So let me just print what A is. Okay, let's see. So the instruction to print, it's just a one line. I just used a print. And let's say you are creating a sandwich, and at some point of time you only have peanut butter and you broke the jar. Now you can't make the sandwich. Okay, and by the analogy of breaking the jar, I mean you created an error in your instructions that the instruction fails to execute. And I will create the same error like this. I will again that B is not happy, but I'm not creating the B as a string. Okay, what string is we will discuss in session 2. B is not happy, so it's throw a error that invalid syntax. You are not using the correct syntax to create correct instructions. So there are a set of rules which I need to follow. But the thing is, I have created this, but and also created an error. But I can access the value of A. Still I can access the value of A. Okay, with that we understand that when we created the copy of our interpreter in the memory and pass this instruction, a is equals to happy, it stored in the memory. Then we pass this instruction like, hey, print a on the command line. It prints a. Then we created some error, but after that error, the program should fail to execute, but still it's in execution phase. And when I say print a, the a was still in the memory. It means that even if one line of statement fails, all of those lines which have been executed uh, uh, before that line are being stored in the memory and not going anywhere. But that's not the case with the compiled language. We will understand. We will see that too. Now let's say this is untitled dot. Let me just rename this thing. Huh? Let me just create a for our just as a fun. We will create a C file. Okay, a compiled language C. Okay, a dot C. This is our C. We have some basic syntax. Don't worry about it. Let's just similar रखते हैं ना इसको चेंज नहीं करता है कुछ भी अभी okay, don't worry what I'm doing here. If you are not getting what I'm doing here, just don't worry. Don't worry whatever this happening. I'm just okay. I'm just explaining you. I'm just giving you an example. Like what happened when we try to compile a compiled language when there is an error, or like you may get the idea. Like what is the difference of interpreted language and compiled language with this thing? Okay, now I'll try to print a again. That's the same thing we does in the case of Python, right? If you remember, we created a variable. What variable is, we will understand right now. After this, we will understand what variables are. Then we created a print statement to print the value of a on the command line. Then I created this thing and it says it's not happy. And then we created a variable a. Now I will try to compile this thing. Okay, so don't worry. ये कैसे compile होता है? बस समझ मतलब. So it throws error. It throws error. It throws one error. Now let's see कि हुआ क्या. Again. Mhm. So ये कहता है यहाँ पे it expected something. There are some error. There are multiple error. Okay, error not undeclared first using this function. Something garbage. We are not going to understand tomorrow or today or whatever. Not anytime soon. Okay. So it entirely fails to compile the program. It didn't execute this statement. It didn't execute print A. It didn't execute the second print A. It just because there is an error, it throws the entire program out of the memory. It 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 rejects to compile the program. Okay. So coming back to this thing. This thing. Wait a second. Coming back to this thing. What happened? We have our compiler. He complained that, hey, mister, You are using an error here. There are an error statement here. What are you doing? What are you trying to do? You can't do that. You can't do like that. Okay. There is an error statement. I will just throw the entire program out of the memory. I'm not going to compile. I'm not doing to this anything. But the interpreter say, okay, you give me this line. I will interpret it. You will give me this line. I will interpret this thing too. Oh, you give me error. No problem. I'll store these things and you can again access these things later on. So by that, we understand that interpreted languages are interpreting or actually they are being run or interpreted line by line, and compiled languages are compiled the whole. That's the difference between compiled and programming languages. Now there are some compiled languages and there are some interpreted languages. Okay, some basics and more popular one. If I talk about C and C++ and maybe Java. Okay, Rust. Now some may argue that Java is not a compiled language, but we are talking very loosely here. Java is kind of a compiled language, but yeah, we are not going to go into the details. I said on the start that this is a loosely difference, that there are multiple, other dynamics to it also. We have some languages: C, C++, Java, Rust. Then here, coming to here, then we have some languages, compiled languages: Python. We have JavaScript. Okay, we have Godot script. Like it's a gaming language. It's a scripting language for game engine called Godot. There is also one more language called Unity script for Unity game engine. Okay, and maybe I just mentioned these if you are interested in game development and so. And maybe there is a language called Lua, and there are many more. I can take many more examples, but yeah, that's it. So these are what interpreted languages. We will understand Python in today's session 2. Mark your calendar or whatever. Okay, and these are our example for interpreted languages. Now I said there are some basic rules or some basic functionalities a language should have so that it's actually useful. So let's make a list of all of those things. First of all, let's say you are working on a project and you have data. You need to store those data, no? So to store those data, first of all, you need variables. Store those data. Now, what variables are? So think of variable as a container. Okay, it is a container. Okay, it has some default size. We will talk about its default size in session 2. Okay, when we go more detail into the language or actually programming something in session 2. Now, it has some default size bind to it to store something in the memory, where in the RAM. I hope that most of you know the difference between RAM, ROM, CPU, GPU, etc. Right? I mean, उसके लिए तो search करा होगा ना अपने college laptop के लिए. So this is what variables is. It just help us to store the data. Now, if I ask you that what is the type of your data? Is it a number? Is it a string? String is a data type. Again, remember the word data type. So now I ask you, what is the what is the type of the variables? Now variables are storing some data. Then what is the type of what is the data types? What are the data types available to us? So now we can loosely can divide data types in 2 or more categories, like uh, uh, custom data types. We will understand what custom data types is. Maybe if we got time today in session 2, custom data types or pre-built data types. Okay, we also called it built-in data types. Okay, default data types also. One more name called default data types. built-ins. Or what was I? Oh, whatever, forget. So we need to store our data. We need variables, we need data types to store the we actually that these data types actually are the thing that are going to define the size of your variable. Okay, so these thing determine the size of your variable, like the whatever the size of your variable is. Okay, the size, let me just color it in. Okay, now we are storing our data. Now we need some manipulation. We need to manipulate our data, right? We can, if we have numbers, we can add numbers, we can subtract numbers. We need some basic math functionalities. Okay, so we have operators. To solve that problem, we have operators. Operator like plus, minus, basic operators. Okay, multiply, divide. Okay, remainder. Or in Python, we have this power operator. Okay, post increment. Or post increment and pre increment भी कह सकते हैं, but yeah, it's not in Python, but yeah, I just included it's a feature from other languages. We have minus minus. We have this thing. We have this thing too. We have many more. We have many operators. Okay, we will talk about operators too. Now we have operators. We have data types. We have variables. Okay. Now, but we don't have comparisons. Sorry. Oh, sorry. My bad. We have comparison operators too. Yeah, let me just include this. We have comparison operators too. This is greater than, less than. Okay, or we have greater than, equals to. We have less than or equals to. Okay, that's the thing. Now we have all of those comparison. We have operators. Now, what if you don't have something? You are making a sandwich. Okay, let me just introduce to one more thing. You are making a sandwich. Where was the sandwich example, by the way? There is the sample example. So you are making a sandwich. This is our sandwich. Let's say at some point of time, you finished finish the jar of peanut butter, but you still have the jar of jam. And you have developed a habit that you first check for peanut butter, then you check for jam. So I can write these instructions a little bit differently. How? Like this. अरे भैया. Here. Okay. This thing. Hey, computer, take 2 pieces of bread. It takes 2 pieces of bread. If there are, if, okay, now we will understand what if statements are. If peanut butter is present, okay, take peanut butter. Else, take jam. Done. Your final statement which you have to execute is make sandwich. Okay. Now I will delete the rest of the stuff. So what happened here? Hey computer, if you have peanut butter, then do this. If you don't have this, then do this. So what I did, I put a condition. I put a check that if something is there, if this condition, what is the condition? The condition if peanut butter present. The condition is peanut butter present. That's our condition. Basically, if this condition satisfies, then what you are going to do? If that condition is not going to satisfy, then what you are going to do? So I put a condition. So we have conditional statements so to solve that problem in programming, we have conditional statements. Conditional statements. Fifth, next thing. Now let's say you want to create 100 sandwiches. Okay. And your computer does not understand the difference between your computer does not understand. Ki, hey computer, create hey computer, make 100 sandwiches, or hey computer, make one sandwiches. What he actually understand, that he understand the instructions. So in our case, you have to give this instruction, computer, how many times? 100 times. If you want 100 sandwiches. Okay. If you want 100 sandwiches, so you are going to give the computer this same statement 100 times, or you can do, or you can do this. You can create a loop. You can create a black box, or not exactly a black box, a function which runs 100 times. So it itself has a condition that I run 100 times. And then what you do, you put this thing inside this. Okay. Simple as that. You have put in this thing inside the computer, inside this statement, inside this program, which runs 100 times. And now this computer is going to execute these statements 100 times. And to solve this problem, we have loops. Okay. And there are different type of loops. We will talk about it. So to solve this problem, we have loops. Now talking about loops, we have while loop. Okay. We have for loop. We have do while loop. This is very basic. This is very basic. Okay. There are some more type of loops, but they are language specific. Okay. Like there are for each, for in loops in JavaScript. So, but that those loops are language specific. So we are not going to talk about those loops. Okay. Now let's moving forward. Loops. Now, what other thing you may want to do? Let's say now what actually you are doing. What is exactly happening here? Okay, where is our checker here? This thing. So what's happening? That hey computer, take 2 pieces of bread. How the computer is knowing that he takes 2 pieces of bread, or what does it mean to take 2 pieces of bread? So let's say there exists some function who, if you give input 2, it returns 2 pieces of bread. You get my point? Let's say there is an black box. There is a black box, and if you give number 2 or some number n as its input, it will return 2 pieces, okay, pieces of bread. That what is does, that what this thing does. Okay, what is this thing? I like to call this thing as function. Yeah, hey, this is what function does now. Function takes an input and gives some output. That's what function does. In reality, in mathematics too, we have some x, we have some y. This is our x, this is our y. Okay, so that's its function. So this means that we are actually completely we are calling a functions, or we are creating some functions, we are creating some functionalities. Let's say we have encapsulated. Encapsulation means this thing. This is also an example of a function. I mean, I've taken as an example of loop, but let's say there is another black box similar to this black box. Okay, sorry. similar to this black box. I will just copy paste this black box here, and it's not a loop, it's a function. Okay, and its name is, what the name? Its name is create pred. Okay, its name is create pred. Now in our Python loop, what I'm going to do, I'm going to remove everything. This thing, this block. Oh, I'm just going to remove this block. Now come back. I run 100 times. You are going to run this statement. What? You are going to run this thing 100 times. So what I did, I created a functionality. I created this functionality which has run. Okay, this functionality, this function, which whenever you calls it, whenever he says, hey, I'm calling this function, I'm I'm saying that do this function, do this. This is a function. This is a function to create a bread, and you are calling this function 100 times. So you are, what you are doing, you are improving your code. So let's say you are running 100 times, and after a while, let's say you created one more loop which create this thing, uh, which runs 50 times. You are not going to write entire statement again. Okay, you are not going to copy paste the entire thing here. So what you did, you will write a one liner which we call a function, which which takes some input and gives some output, and necessarily, and it is not necessary that it always takes some input and always gives some output. Okay, we will understand how functions work again session 2. We will try to cover these things in session 2. I mean, session 2 will be more uh, more technical function. 7. Now we have function, we have loops. We there are some, then we talk about advanced things. What advanced things are? Let's not increase the length of this section, but advanced thing include creation of data types. So we declare these things. Okay, we declare these things as data types. I say that we have custom data types, we have pre-built data type. So the creation of custom data types comes in this thing. So the advanced programming is responsible for creation of custom data types, and there are some more things related to custom data types. Okay, we've discussed this error thing. Okay, we have discussed this error thing here, if you remember. So this error thing. Now let's say you don't want this error to happen. So there is something called error analysis. Not error analysis, man. This is called try catch loops, or uh, handling error. Okay, so in advanced things, okay, it's a concept of advanced thing. So I will just ident it. Not advanced. Okay, handling error. Okay, or it could be creation of custom data types. Okay, and this is, if you have these things in a programming language, if you have these things in a programming language, your programming language is complete. Okay, your programming language is complete. If you have the knowledge of these things in some programming language, I guarantee you can literally do anything in that programming language. You just need some more guidance, some more documentation, some more extra examples. What you can do. Okay, you can create your own softwares, create your own games. Okay, create your own functionalities. But again, you need to understand some more concept before that. Those are some advanced things uh, which are not entirely related to programming, which is more of related to computer science. Okay, like data structures and algorithms. है ना? That what are efficient algorithms, what is big O notations, what is time analysis, okay, what is the space complexity, things like that. It's not entirely related to programming, but you have to, you should have knowledge of those topics to be a good programmer. So we have covered this thing, the basic structure of programming. Okay, we will try to understand how we will try to program in later sessions. Okay, let me just red color strike. Now let's see what GitHub is. GitHub is maybe the best thing you have ever heard of, because at least this is the best thing for me. If I ever wanted to showcase my projects to anyone, I will just give them my GitHub ID. You are going to create some awesome projects in your 4 years of your college. Okay, some of you are going to create drones. Some of you are going to write complex algorithms. Some of you are going to use machine learning to solve complex problems. Okay, but more or less, you are going to work with GitHub. Okay, there is no exception to it, because of course it is a free version control system. VCS. GitHub is a version control system. Now let's try to understand what GitHub is. Okay, and then new page. It's look good. Now let's say this is GitHub. Think of it as a stack. Okay, this is a stack. This is a GitHub. And what you are doing, you have a project. You are working on some project. And when you are working on project, it's obvious you are going to make some changes to your project. Okay, you are going to try some additional things. Let's say you are working on a website. So you are going to check, like, is red color looking good? Is white color looking good? Is black color looking good? Okay, you are going to do that. Or maybe you are going to create some more functionalities. You are adding some new features to it. Okay, you are maybe your feature created a bug. Now let's say you have to go back in time. You want to go back in time to that particular feature, the uh, to back in time before that you implemented that feature. Okay, so that you have a perfectly running code, and that's where GitHub helps. That's only one use case of GitHub. So what it does, it records each changes our GitHub, each changes our project, each changes we make to our projects. Okay, so this is our project. This is our project. We are changing. We are constantly writing something into it. We are constantly doing something. We are constantly making changes. I'm going to highlight changes with red color, green color. Okay, so you stored this thing. Okay, so what you did, you add this thing to the GitHub, your GitHub account, your GitHub repository. Repository is like a library of your projects. Okay, we will get into details in later sessions. Okay, I mean when you come to college, most probably in let's say in 2 months there will be a session on GitHub, but I will try ki we will take more sessions like this. Okay, so you stored the version 1. Let call this thing version 1. You are still working on your project. Okay, it's still in its development phase. It's still in its starting phase. You started the project. You have created your initial commit. Okay, what word I use? Initial commit. Okay. So what initial commit is? You have created your project. You have add everything to the GitHub, and that's your initial commit. Or you can say that that's my version 1. Okay, stroke width is too much. Yeah, that's my version 1. Okay. Now moving forward, let's say you created some changes in your project. You have removed this line. You remove this line. You remove this line and added some more lines. Okay. I highlighted changes in green color. Okay, this is the changed code. So what GitHub actually does when you try to create more versions of your project. This is version 2. This is second commit. Okay, that's not necessary to be called initial commit. You can call whatever you want to call it, but in general we just call it initial commit. And for second commit, you just mention what changes you made. You added a feature, you remove a feature, you change a color, something like that. You may get the idea. Okay, that's version 2. That's version 2. Okay, v.0. And what it does, it sees where changes are made and only changes those sections of your code in your in the online repository which is stored on the cloud. Many of you have heard about cloud. Okay, so GitHub, actually you are storing your projects on GitHub. Let me actually show you how this thing happens. Okay, let me show you. Let me just show you. Is this see? So this is my GitHub repositories. Okay, we will take this one as an example. So this is the project which I was working on. Okay, a few days back. Let's say we will go into Insight. We will check for commits. I use the word commits. Remember, I use the word commits. So what happened? On Sunday, I made 11 changes. It shows me that on Sunday, I made 11 changes. On Monday, I made 4 changes. On since Tuesday, I haven't touched this project. Project's been completed more or less. Okay. So let's see, exactly see where the changes. Okay. I clicked on this thing. So, mm, see, so all of the things, you can see the code here, right? This is some basic code. So what happened? Wherever there is red and where there is green. So this is the red. The red part is the part where I made changes. The green part is the final part. Okay. Also, there are, see, some few lines are being created. Line number 74. This thing. Line number 74 is created, and there is no line. There is line number 74, but I created one more statement. So over number of lines just increased by one by adding this blank space. It also records blank space. It just records your changes, whatever the change I make. See, here I have image source asset something like something, and I changed with this thing. It records this. Okay, this red thing was removed. This green thing was added. This is what GitHub does. It 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 remembers all of the changes you made. It remembers all of the changes you made. Got my point? That's our GitHub. And now you can actually see other repositories too. Okay, many people have different repositories. Let me just go back. Shit. So there are different type of projects which I was working on. Okay, let's see. Maybe anyone like there was. Uh, okay. So, oh, sorry, my bad. Next second. So these are all of the projects which I am working on or previously I worked upon. Okay. So see, let me show you. This is a game which I worked 3 years ago. Okay. And so again, you can go into insights. Okay, you can see commits. All of the commits I make. There was only one commit, by the way. There's only going to be one commit, single commit, one commit. As I said, on Monday, I just made commit and just copy paste the entire code base to my GitHub account. Okay, now I stored the GitHub account on my as an online reference. You can use this as an online reference. You can use this as a learning platform too. Other people also contribute. There is also called contribution. I contributed to other people's code also. You can do that too also on GitHub. Like if you have heard about GSOC, Google Summer of Code, this shows all of my contributions over the year. Okay. In 21, 22, almost close to no contribution. I was working on my J. Okay, studying. And then 24, some contributions. Okay, now I will show you some contribution which I made. Back. This thing. So this is our online project. Okay. So this project is done by Gopi Krishna Sonam. He is an alumni from IIT Madras CSE, and I've worked with him over this online JavaScript environment. Okay. It's something we will talk about it in some other day. Okay, coming back to our list. GitHub is more or less completed. We will talk about other things. Okay. See, copy paste. Now, what is command line interface or CLI? Let's try to understand. Okay. And there are some Q&A opening on. Is anyone chatting? Right, explain this. Right. So let me just share my command line interface with you. Okay, all of it. Okay, everybody can see my screen. See, so you can open. If you are on a computer, you can open this dialog by clicking Windows and R. Okay, Windows and plus R, and you can run here PowerShell or CMD. Okay, so this is what command line interface is. Okay, this is a command line interface. Now, how it's work? Now, what exactly command line interface is? Now, think of it like in primitive days of computers, or when computer was a new concept. Okay, so most of the computer does not have graphical user interface. What graphical user interface? You are seeing this seeing you're seeing my screen. Okay, right? There are different icons, icon over these things. Okay, there are different types of icons. I can interact with these things. I have a cursor, I have a keyboard. Okay, I can click, i can I can open something. That's a graphical user interface. It's graphical, it's purely graphical. Graphical means we have graphics. But in the old days of computer development, we have command line interfaces instead of graphical user interface. So what command line interface, it gives ability to do the same thing which we done with the help of graphical user interfaces. But to be honest, command line interface, the user experience for command line interface in Windows sucks. It really sucks. The best experience I ever got was in either in Apple or in Mac, or either in Apple or in Linux. Okay, Linux has like a gigachat of all terminals, because most other things you are going to do on terminal. You can't survive in Linux without terminal. Okay, you can actually, but I mean, to be a good Linux user, you should learn a command line interface, and learn more about computers, how's computer work and how operating system work. You should also learn about command line interface, because it directly gives you, again, if I go back to this thing now, this thing. So above programming, I can create a one more circle, and in this one more circle, you can think of this circle as command line interface. And then if I create one more circle, that's our user interface. Okay, now it's been a mess. That's why I don't want to do this. So this thing, this circle, the bigger one, the green one. Okay, this is our graphical user interface, and the brown one is our command line interface, and rest of the abstractions level. Okay, moving forward, where we कहाँ गए? So sorry. Yeah. So this is our basic command line. You can type commands like ipconfig. Okay, you will get these commands. है ना? Give me a second. Oh. So, where was I? So you can type commands in it. You can also one more thing, that you can create scripts. Also, like we have programming languages like Python. You can create scripts in Python. And if you don't know what a script is think of script as a, like, the in literal sense. What script is? Script is something actor or actress read then perform. Similarly, computer reads and perform. That's what script is. Nothing else. That script is basic idea. Okay, you can create scripts in this thing, Windows. It uses now there are different type of command line interfaces. Now this is command line interfaces. Now command line interfaces uses different command line shells. Now what the heck shell is? Now again, just like I instantiated an instance of Python, the shell is an instance which give us access to some functions from its memory. Likewise, I use print to print something. I used ipconfig to get this all of the details about my IP addresses and something. I should blur this stuff, but I don't care. Okay. So now, okay, now moving forward, what should I tell about command line interfaces? Do you have any questions about command line interfaces? I want to ask. No questions?
No.
So K just asked the question. Okay, I will try to answer this question at the end of this session. Okay. Um, so this is what command line interfaces. Now there are some more commands. Okay, they're like, you can change directories. Okay, you can list directories. Okay, that's why it sucks. That's why it sucks. Like most of the command line interfaces uses the same thing, uses LLLNS as commands, but only the Windows command line system does not use this. It has its own system. I don't know why. Okay, even the PowerShell has ls command. It uses shell. It uses a different script. It uses Bash programming language or Bash scripting language as a shell. You can type ls here, and ls just returns me all of the list of all the, the stuff or the directories available in that in the folder. I can see, there is command called who am I am Dhruv. Like I am the user Dhruv from computer Dhruv. Okay, if I go into admin, okay, I can't do that. Sudo. Oh, I also can't do that. I generally don't use Windows command line interface. I mostly use Linux command line interfaces. It's super cool. Uh, the Linux command line interfaces. Maybe I will take one session on command line or Linux also. Linux is a quite interesting operating system. So CLI is more close to processor than terminal. Well, terminal is CLI and CLI is terminal. So this thing is called terminal. This thing is terminal and this thing is called command line interface. Okay. This is command line interface. This is terminal and CLI more or less mean the same thing. Okay. I think I should strike through. Moving on to operating systems. Now talking about operating systems, you are not going to understand how operating systems are going to work or what operating systems are. I'm just going to differentiate different type of operating systems. You have options of, some of you have chosen Mac. I don't know, I just hate Mac. Then there is Linux, and then there is Windows, and there are different flavors of Linux. Okay, and by flavors, I mean that there are different versions of the same thing. Okay. Not exactly, not calling it a version is the wrong thing, but you, but it's okay if I call it now. Okay. For this session only. Uh, so now why Mac? Why not Mac? See, Mac is like super egoistic. The Apple does not want that anyone else from outside its company want make software on it. Okay, Apple does not support open source, so you are going to have hard time running something running some like something softwares like open source softwares or pirated softwares on MacBook. Okay, you are going to have hard time dual booting your laptop. They just make it harder for anyone to experiment with their laptop. They don't want you to explore. They don't want. They just want to use our laptop as it is, and after 1 year, when we bring M4, M5, scrap our M3 and purchase M4. This is the main philosophy of Apple. Still, MacBook is a really powerful computer. Okay, it had really good battery life also, and but in general college use case, I guess Windows or Linux is preferable options. Okay. Now, also in your CS department, okay, if someone is from CS, or most of the people in their first year in most of the colleges in India take CS courses, and their CS exams are going to be held on Linux, not on Mac, not on Windows, on Linux, because Linux is just like my favorite operating system is, to be honest, Linux. Okay. I have multiple reasons to it, but that's just out of scope for this session. We have three operating systems: Linux, Mac, and Windows. Then there are some other operating systems like Temple OS, but that's just uh, it has some lore attached to it. And then there are DOS operating system, which was on which the Windows operating system was based. Then there is Unix, on which the Linux is based, and there are multiple things like that. Okay, Mac OS is also based on Unix. That's why Mac's command line interface and Linux command line interfaces are better than Windows. Much better, like 10 times or 20 times better than Windows. Now the fun part: Docker, Kubernetes, and CI/CD. Now we have discussed on operating systems. Okay, I also want to uh, tell you one thing about operating systems. Again, what operating system says? Operating system is just a piece of software which is running on hardware, right? It is a piece of software which is running on hardware. That's a operating system. Now there is something called virtual machines, okay, or virtual environment. I have one. Let me show you this thing. Karya Oracle VirtualBox. So what it does, it gives me access. Like I can use some other operating system while being on Windows. So I can use either Kali Linux or GeroSafe, another version of Kali Linux. Same thing. Okay, this one is not working. This one is working. I can't run it because it's extremely resourceful. Okay, but yeah, uh, let's just run it. Okay, coming back to this thing. Oh, Obsidian. So what VirtualBox does is it gives us the ability to use some operating system on on our use some operating system while being on another operating system. I can use Linux on Windows, or I can use Mac OS on Windows. I can use Mac OS on Linux, or permutation, combination, whatever you want to involve in it. That is uh, VirtualBox. Now, what Docker does is, now there are many things related to operating system. We have softwares like photo softwares, we have PDF softwares, we have different things. But I've talked about command line interface, and I said about that command line interface for Linux is very good. Anna. And you can do almost anything with command line interface, which you can do with graphical user interface. Obviously, you can't make something like this on graphical user interfaces. You need user experience. You need eyes to watch what you are making. Okay, right. So that's a different story. But so you can more or less do anything on a command line interface. What happened? 100% powering of VM. Let's start now. I'll show you like running the thing. Okay, so that what VirtualBox does, but it created a virtual environment for operating for my Kali Linux system. है Kali Linux ISO. So I can run my Kali Linux on Windows. Now what Docker does, it creates a box or a container similar to this container. This one container. Now what Docker, this is the Docker. It uses something called Docker images. Docker images is nothing but a set of instructions which is useless to build an operating system. Okay. Or build an operating systems, like I've talked about scripts. It uses an operating system and runs some scripts on that top of operating systems to make it, you know, more favorable to whatever the work we are doing. Let's say I want to do machine learning. So I have some scripts, I have some Python libraries, and I've created a Docker script, which I run Docker image, which on running creates an instance of an operating system, which is going to be Linux. Because Linux, first of all, is very good. Linux is the backbone of internet, and Linux is very light. Okay, well, that means, I mean, it uses very less resources. And something happened to my VirtualBox. So that what Docker does, it created an operating system inside a container, and I can use that operating system from my command line itself. I can use some other operating system from this command line itself. Okay, I can run command from here also. Okay, like I can do this. I'm not going to do because it's extremely resource heavy. Even 16 GB RAM is terrifically less for that purpose. Okay, so like Docker run. Okay, maybe ML container. So it containerizes an instance of an operating system. If you are working on Linux, it's containerize that instance of your operating system with necessary libraries, with necessary scripts, and make a image for you, and you can run that image. And you can run, and that image is just the size of an megabytes, just in size of megabytes, literally like 2 megabytes, 3 megabytes, sometimes in kilobytes also. And you can upload us, give that image to someone else, and that person can download an image and run your script. This is your, let's say, script, and this is of 2 megabyte. You give this to someone else, he or she execute this or run this image, created a container on their Docker machine, and have 16, 17 GB of data just in a matter of seconds. That was that Docker. That Docker does. Now why we need this? Okay. Now it's related to this thing. This thing. Where is this thing? This thing, nah? This thing. Our backend, front end DevOps. Okay, like mostly is the concept or the technology is mostly used in this thing. Okay, now talking about what is this? See, Docker containers are a way. If you are working for a backend project on a laptop, so then what you did, you created a Docker image, uploaded it to a server, and that only took 2 minutes. And that server created a Docker container, and that server is now running your backend. Let's say you are in America, you are in India, and that server is in America. You are using AWS cloud services, and that server is in America, and you're using that server, and it created the image using your script in just a matter of some seconds. Okay, that's what that Docker helps. Okay, more or less. Now, what Kubernetes is? Now, Kubernetes is for Swarm networks. Swarm. Swarm means join. Okay, texted actually. Swarm networks or Swarm containerization. Swarm networks or Swarm containerization. That was Swarm network, Swarm containerization. What it actually does, it help us to deploy our Docker image to, let's say, millions of servers, millions of computers, thousands of machines, just on click, just on one command. That's help us in. That's what the purpose of Kubernetes. And what is CI/CD? That is continuous integration and continuous development. Now, now you can integrate. Where is it? Now you can integrate this Docker container and Docker machine and this Kubernetes with your GitHub also. And now whenever you make changes to GitHub, all those changes are going automatically going to the server. And your website, let's say you are a system admin for YouTube and you change the title for YouTube for MeTube. Poor joke, I guess. And you change the title for YouTube to MeTube, and you just did that, and in the entire world, all of the servers of YouTube are just going to repeat the same step. They are going to repeat the same step. That's the power of Kubernetes. That's the power of Docker. Okay, and most of the time it's free for student users. And now CI/CD is continuous integration. What continuous integration? You have GitHubs, you have Docker and Kubernetes. You are continuously integrating your changes to it. You are continuous integration, continuous development. You are continuously developing your project. You are deploying your project. You are maintaining your project. That's maintenance M. That's for deploying D. That's for development dev. And that's for for spreading your data to the world. You can think of it as Kubernetes. You are developing, you are developing your project, you are deploying your project, you are maintaining your project, you are also making changes. Okay, but also comma D also, because you have to deploy this project here also. You can download a project here also, and it's a continuous cycle of integration and development. And that's a concept you may be interested, but I should say learn at least 2 3 programming languages. Okay, made 5 to 10, make 5 6 projects, and after this come to this, because if you are going to start with this thing, it might be of no immediate use, okay, of your time. But yeah, knowledge has never been wasted. अरे 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 क्या हो रहा है? Okay, we have 15 minutes left. We will try to cover backend. We will try to cover these things, okay, as of now. Backend, okay, spoke with. We will try to cover backend. We will try to cover APIs. Okay, as of talking about backend, front end, and DevOps. So let me show you some website. Okay, we will go to obviously Google Doc. Now on your screen, you can see we have some text. We have a input box. We have some links, Gmail, images, some more interaction available. Okay, all of these things which you can see in front of your eyes is called front end. It is a task of a front end developer to develop these things. It consists of all of the interaction which is going to happen. Okay, like the presence of this suggestions, highlight of links. Okay, in the bottom you can see here, I mean HTTP about Google in the bottom left corner of your screen. Okay, if you are going to click on this thing, then this thing is going to happen. This is a task of a front-end engineer. Okay, if you are going to click on this hamburger type of menu, all of these are apps going to show you this. This is a task of a front-end engineer. If you are going to inspect, now there is something called network, and this network is coming from somewhere, right? Okay, and someone is handling these networks. Someone is handling all of these requests. Like what is exactly happening? Like if someone type in their user URL HTTP Google, what's going to happen? It's going to send bunch of requests. See what happened. It's going to send bunch of requests to google.com. Hey google.com. See, I've requested for HTTP HTTP double colon slash www for, then it's going to return me this. Okay, I have different method, post get. We will try to understand in some other session. If there if I mean on web dev, specifically on web development. Okay, this thing now now the thing is, that's the task of backend developer. Now I said that you need to deploy your backend server, your front end script to some server outside your country, outside your city. You use Docker and Kubernetes. You use CI/CD cycles. That's what DevOps means. That is what backend. That is front end. Backend is whatever you are not seeing. That what's in the back, what's on the server. Okay, backend code is not going to come onto your browser. Okay, you do user authentication. That's backend. Okay, like whenever you are going to some website, you are going to sign up, and when you click sign up, all of the data is being sent to the server, and the backend handle that data and return an instance of or give you access to their front end or the specific website you are asking. Okay, that's some difference between backend and front end. And what is application programming interfaces? API. Now again, come here. Binaries created a level of abstraction. Assembly created a level of abstraction. Programming created a level of abstraction. Command line interface then created a level of abstraction through graphical user interface. Is the what happened? This assembly is the father of all things. Then we created some APIs in binary plus in assembly and given access to a, let's say, a Python developer. I'm a first year student. Okay, I want to print something on the screen, and by printing there are thousands of processes which are going to happen. When I say print A is equals to happy, there is, let's say, 500 or 600 instructions are being sent to the machine. When I click enter, there are instructions being sent. Okay, but I don't have to worry about everything. I just have to know how to print something on the command line. I don't have to worry how the Windows is handling those things, or how the compiler or interpreter handling those things. That's the task of APIs. API give access to certain features to the compiler. That compiler give access to it some features using of API, like print function is also kind of an API. It give access to let us print something on the terminal. Okay, to give to print something on the output of our terminal. Okay, output stream. Now I'm talking about, there are different contexts of APIs also. Let's say you are an aerospace company. I'm an aerospace department. Taking an example of an aerospace company. I'm an aerospace company and I have a popular software. This is my popular software. And in this popular software, you can fly planes. Very bad plane. Okay, this is a plane. You can fly planes in the way, or you can create simulations using scripts. So what I did, I give you access to my API. I give you access to my application programming interface, that, hey user, I give you these functions. Let's say I give you 10 functions in my API, and you use these 10 functions and you will be able to fly this plane. Or you are google.com. You are YouTube actually, and there is someone who wants to download a video. There are multiple YouTube downloader available online. Okay, so what you did, you charged $10, $15, I don't know, $10, $15 for your API or access to your API. And what this developer does, it has access to your API. It has access to the functions available in your API. and uses those API to download something. Okay, he does not have to write everything. He does not have to write entire YouTube from scratch. He can use the API, YouTube's API. He has not to write an entire YouTube. Okay, so that's how APIs reduce our our task. It helps us to focus on our important things. If you are working on a project, let's say you are working on a web development project, so you are not going to create a browser for your development. The browser is already there. You are not going to create literal system calls. You are not going to create animations or how animations are going to work. Their APIs are being provided by the browser so that you can use. Like in web development, there is Canvas API you can use. Okay, and I can use Windows API. I don't have to actually write. Okay, you may have heard of drivers. Like you need GPU drivers. Okay, in that case, you have purchased a new laptop. Now now you are downloaded CS:GO. CS:GO is running on 20 FPS. Your GPU is RTX 3050, and still your game is running on 20 FPS. What's happening? Your computer is not recognizing that there is any any GPU, because what? Because the GPU has its own set of APIs that had need to be programmed to the hardware so that it can interact with the GPU. That what driver does, GPU driver does, that was Cyan driver does, that was webcam driver, camera driver does. Okay. They uses Windows API as a helper to, to create an abstraction around all of those hidden details or complexities of a computer. You are not going to create sound drivers. You are just click play and the sound is going to play. Okay, and all of those hidden details are going to work in the backend. That's APIs. And that's it for today, I guess. And now किसी को कुछ discussion है, ऐसे doubts है तो बताओ. We will take those, okay? Or just an informal section. And say discussion करना हो कि बात वगैरह. The meet is officially over. Wait one second. Let me just end it officially. PPT. Yes. We have covered everything. एक second. See you all. That's it. See you all. Okay. So yeah, someone Harshit has got out. Yes, Harshit.
मैंने ये पूछना है, जो लिनक्स होता है वो हम मैकबुक पे पैरेलल्स की मदद से यूज कर सकते हैं?
मेरे कुछ दोस्त हैं, तो उनको देख इशू आया था लिनक्स वगैरह इंस्टॉल करने में, बहुत ज्यादा इशू आता है, तो मोस्ट ऑफ द टाइम जनरली लोग यूज नहीं करते हैं, है ना, और शायद दिक्कत आती है काफी. और मैंने कभी मैक में लिनक्स इंस्टॉल करा नहीं, और ना मैंने किसी को सुना है मैक में लिनक्स डुअल बूट करते हुए. इट्स वेरी कॉम्प्लिकेटेड एंड हार्ड स्टफ. बट if you are if you are a good person who can search on Google, you can do that obviously.
Okay.
Yeah. Now there is एक बंदे किसने डाउट पूछा? नाउ के ने डाउट पूछा था. के एजेंट के है क्या? सर फर्स्ट ऑफ ऑल आई एम नॉट सर, मैं भैया हूँ वैसे भी, और मोस्ट प्रोबेबली तुम मुझे नाम से बुला सकते हो, जस्ट एक साल का डिफरेंस है. How you learn all these things? Because I have interest in computer science. Okay, first of all, my interest, I really like to I want to learn new things. I love to learn new things. Okay, and all of this started just from a basic question. Like I have explained कि assembly से binary convert होता है, but how the heck they had created something है, they are binary, चलो समझ में आता है. Now तुम्हें assembly पे कैसे चलेगा directly? Now you are giving English instruction and it's converting into binary. That's what intrigued me, and that's what started me learning about computer science and programming. I'm still finding the answer for that question. Okay, and how other branch student other than CSE can learn about this sources. Yeah, I totally forgot to mention sources in this class now. And so what I will do, I will compile a document and I will compile a document of every resources which is necessary. I mean, you can go and start about it, or you can learn from those sources. Also, I'm thinking of starting a course teaching Python. So, should I do that? Anyone of you, if you are interested, like teaching the entirety of Python. Say yes or no. I guess this is an interactive session.
Yes.
Yeah, if you don't want to talk, then you can just raise your hands. Okay, Akito, do one thing, just float the document doc form on the WhatsApp.
Yeah, sure, man.
And रही बात बाकी चीजों की, so there are multiple things on which we can still talk about. Okay, like apart from CSE, like बस एक काम करो, can I ask form वगैरह कुछ, can I do one thing? I can't ask what happened के. Bhaiya, can we download anyone's code repositories from without? You can do that. It's open source. So what's happened, Ankush? That everything on GitHub is open source, and you're free to download. Free to download. Okay. There are multiple softwares which are open sources. Okay. I can just. I have one software. Maybe I have. Okay. This one, GIMP. It's a photo editor. Okay. I have this GIMP photo editor, and I can use this as a what? I can download the source code, I can edit it, I can do whatever I want to do with the source code. Okay, but the thing is, let's say you are working on a project and it needs the citation from that source or something, like someone created a driver from created a sound driver, and you want to use that sound driver to create your music player. So you can mention that for function person. You can mention that person that, hey, uh, I used your project in my project, and it's totally okay. The it's open source for a reason. Okay. Like I can show you if you want, I can just show you how to download stuff. And I can go on screen. Where is our GitHub? So first, what you need to do, remove this. Go to github.com, create an account. Okay. They have very good website also. Create one account. And after a while, also one more thing, that you will get a college email address, college email ID, and you can get many softwares for free. Okay, some like those software which charges 2,000 rupees per month, you can get them for free for 4 years. That's a big deal. Same goes for GitHub, and they have very nice UI. Okay, you can see that, and create an account. And let's say you want to download some repository. Okay, let's go here. Pulse it. Yeah, I want to download that. Sorry. Let's say, for example, TensorFlow. Like, click on anything. Now I want to download this thing. Now, so what I will do, I will copy paste this link. Copy. Okay, I will copy this link, and I will go to my terminal. See, first of all, I'm going to change my directory to, or I will just open another terminal in my doc. Okay, I will create a directory, name temp. Okay, I will change to that directory. Temp, sorry. I'll change to that directory. Then I will type a command git clone, and then I will type the URL cloning into TensorFlow and wait for some second. Yeah, it's a big library. It will going to take some time. Wait a second. It's too big, I guess. 1% is 500 MB, 500 kbps. ओके 10-15 मिनट लग जाएंगे. छोटी लाइब्रेरी देखता हूँ मैं, है ना. तो छोटी सी मैं अपनी लाइब्रेरी देख लेता हूँ. योर रिपोजिटरीज ML assignment ls2004. Copy the link. Okay, I will come here. Control C. Git clone. Copy paste the link. Click enter. Cloning into and the receiving objects and the C. This one is the smaller repository. So just fast. Wait 5-4 seconds. Till then, anyone any questions? Bro, how is college life? We get time to do other stuff. Easily. I mean, at least in my department too. I mean, aerospace department is too chill. But speaking honestly, CPI is the most important thing. Okay, work on your CPI in your college life. And I'll try कि fatal error ये पता नहीं less कुछ नहीं है. अरे कुछ तो error आ गया. ठीक है, you will get the idea कि किस तरीके से क्लोन हो जाती है. कुछ तो एरर आया है, बाद में उसको मैं देखूंगा. ओके, सो काफी एक्स्ट्रा टाइम करने को काफी स्टफ मिलता है. जब तुम इनिशियली आओगे तुम्हारे पास बहुत फ्री टाइम रहेगा. बस फॉलो वन और टू थिंग्स. डोंट मिस एनी क्लासेस. there are going to be classes related to HASML also. Okay, classes like for psychology or maybe philosophy. Okay, arts, economics, entrepreneurship. Okay, some classes are maybe which you don't find interesting, but still you have to attend them. You have to get a decent score in all of them because मेरी बहुत गंदी CPI आई थी. फर्स्ट और सेकंड दोनों में आई. So I'm just talking from my experience. Okay, I have done say Python till 12 functions, scope, flow of control, etc. You will teach extra in this course you are talking about. I mean, it depends on the response. Ion, what civil? I didn't understand. In civil, I mean, asking about time. Yes, you get enough time in civil also. Civil is kind of a chill branch in first year, to be honest. Any more doubts or discussions you want to talk about, or anything? Or any suggestion for session 2? That's the important thing. For in session 2, I am thinking that let's actually learn Python also. Okay, let's learn Python. Okay. What is CPI? Is it CGPA? Same thing. CPI is like the CGPA, same thing. It's the same thing. Is it CGPA or any more questions? Any more doubts? Any more discussions? Girls, boys ratio is good. What do you mean by that? You are asking or what? I don't know, bro. Girls, boys ratio is very bad. It's like 9:3. Not 9:11:3. I have calculated. Any prerequisite for next session? Nice question. Uh, uh, I mean, there is no such prerequisite. I mean, it's a very basic session, yeah, but if you have a laptop, it's a very good. If you don't have a laptop, just if you have a copy pencil, just write down the things which we are going to discuss. Okay. I will just post a tutorial on WhatsApp on installing Python. Okay. And VS Code. Install those things before 9 p.m. I mean, what should be the time for session 2? Should it be 9 p.m.? 9 p.m. to 11 p.m. I know C language without DSA. Should I learn C++? Yeah, go for it. I mean, C++ is just an extension to C. Okay, like yeah, there are some basic features which are not available in C, which are included in C++. So you can learn C++. Also, like do both of these things parallelly. Okay, do both of these things parallelly. I have PyCharm as ID for Python. Will it work? Oh, absolutely, absolutely. It will work. It will work fine. Any ID will work. Any ID will work. Okay, just Py ID is important because it just give you you know what some additional features. अरे भाई 9:11 नहीं 11:4 यश yeah do something bro Harshit, do something, don't waste your time. I mean, if you really want to waste your time, then waste it while learning something or making good relations. I know I'm not talking about relationships, I'm just talking about good relations with your family and friends. Okay, go somewhere, go on outings, go on. Okay, enjoy your day, enjoy your pre-holidays before coming to college because college is going to be active. I had downloaded VS Code, but it is showing pip not installed. Can you share good installation guide? ओके यार श्योर द पिप पिप के लिए एक मैं वीडियो सजेस्ट कर दूंगा सो anyone can just if you have any problem before the session just can DM me or Akshat ke Akito the second admin of the group. Okay, you can also message him, text him, and if you have a problem related to this thing we'll just I will just post a video related to that. Okay. By the one thing I want to ask is how many of you are from what's that? How many of you are from IIT Bombay? Raise your hands. But coming to IIT Bombay. Nice, nice, nice. Good percentage of people, I guess. Where are you? So most of the people are coming. Man, okay. Any more discussions? Any more doubts? ओके कूल नैन थोड़ा एंजॉय करो खाना पीना खाओ घूमने जाओ बाहर अच्छा लगा सब लोगों ने इतनी देर तक इसे अटेंड किया ओके I shall end the meeting. See you all in second session. Okay.